are in listen-only mode.
Hi, everyone. Welcome to today's Performance Virtual Groups meeting for December. We do have SolarWinds as our sponsor as of last month for another year. So thank you to SolarWinds, and we'll go into a little bit more on that. All right, so the group today. My name is Leslie Weed. I'm your moderator. For the Performance Virtual Group, I know we still have our old Performance Virtual chapter on some of these items here, but for our social stuff, we've got our Twitter, our hashtag website through sequelpass.org, and then, of course, our email. So feel free to reach out anytime. If there is a topic you are looking for somebody to speak on, we can go track down speakers to find that topic for you. If you'd like to be part of the Performance Virtual Group, more on the board, and help us organize and do stuff, please reach out and let me know. And so technical assistance, hopefully you all are familiar with GoToWebinar, but if you are new, we do recommend you maximizing your screen. And if you have any questions or are having problems with audio, just type in the chat window and I will respond to you directly. So nobody else will see it. You can just ask me directly and I will try to help you with any technical issues you're having. All right, so again, thanks to our sponsor, SolarWinds. They really help us do a lot of cool things. They will be doing some presentations this coming year in 2020. And during their presentations, we will be giving away $200 gift cards. So make sure you're going to join those in the future. All right, so a little pass update. We do have a new board of directors out there, Mindy, Melody, Chris, and Hamish. So hopefully you guys are familiar with that. This is a great crew. Really looking forward to seeing what ideas they bring to the table this next year for PASS. If you did miss PASS Summit 2019 this last month, the download and content is available, so you can get on pass.org to find that. And just a reminder, we've got a lot of different virtual groups out there. Hopefully you guys visit pass.org on a weekly basis just to see what the new, what the webinars are out there coming up, etc. Upcoming SQL Saturdays, quite a few coming up in January and February. Hopefully you guys are signed up for one of these if it's in your area. And just a reminder, PASS does have a career center where you can go and see jobs and post resumes and all that good stuff. All right, so today the most important person, David Klee, is with us. So excited to have David with us. I know a lot of you know him. He's a fabulous person in our community, and he's going to talk about Zen and the art of the baselines. And I'm going to make him presenter so he can show us all his cool stuff. All right. All right, let's see if this works.
Sweet. Hey, I just saw on the screen, it looked like the broadcast still needs to be started. Can you triple check on that?
Oh.
Unless my screen had not updated right.
It might not have updated.
Just want to make sure that everybody's on.
The whole.
Okay.
This session is being recorded. We should be good.
Okay. Perfect. Yeah, just wanted to double check.
Okay.
Awesome.
Thank you.
Cool. Well, hey, thanks everybody for giving me some time out of your day. Hopefully you're enjoying either lunch or breakfast or pretty much anything. This is Zen and the Art of Baselines. Now, I don't want to sound preachy or marketing or anything like that, but if you're taking a vacation in some super scenic area, somewhere out in the world, just trying to unplug and get away, if somebody asks you what your SQL servers are doing on that day of the week and that time of the day, you should be able to know roughly what to expect, because if something is going wrong and it's way outside of the norms, you need to be able to recognize this really quickly. There's a lot of capacity management tools out there. There's a lot of really good, smart people out there. But if we don't have a baseline, if somebody asks you, why is this thing slow? You're completely subjective at that point because you don't have anything to compare against to say, this is running fine, or yeah, something's really wrong. This is way different than normal. So my name is David Klee. I am the founder, and I call myself the Chief Technical Exorcist for HairFlux Technologies. I'm lucky enough to be a Microsoft data platform and a VMware vExpert. I have a lot of fun with this topic. Bottom line, we do a lot of consulting around the whole it's slow, make it faster, or how do I save money on SQL Server licensing, things like that. So what you're getting is a lot of the methodology that we go through day in and day out, and we have a lot of fun with this stuff. So just a little bit of a case study. One of our customers, and honestly, they're one of my favorite customers, they're a very large credit union group. They have this third-party vended app, and I'm just going to refrain from making negative comments about it, but we've all been there. They have a nightly batch process that was running slow. Took about 6.5 hours to get through this process, 6.25. They had an 8-hour window to run this in, usually 11 p.m. to about 5 a.m. And it would basically go through and just calculate all the financials for the day so that when people were ready to get on the online banking the next day or in person, it would have everything ready to go. The machine they were running this on, physical server, 48 physical cores at 2.8 gigahertz, they were about to double their user volume. So they needed this to run in the 8-hour window. They went and figured they needed to buy more equipment. They thought the current machine was running like this. I mean, that's a beast. That's a monster. There's a lot of CPU on there. Let's buy bigger. They went and bought an HPE Superdome X, monster machine. 384 physical CPUs, 768 logical cores. There were 24 core Xeon CPUs at 2 gigahertz apiece. They had 12 terabytes of RAM in it. It could have gone up to 48 terabytes total. The thing is just a monster. All flash storage underneath. They migrated the workload over to it and then reran the nightly process, and it ran 21% slower. Not cool. Not a good thing when you're expecting to double your workload over the next 6 months, and they had to run it in that time frame. So what do? Well, they called us, and we went in and took a really good look at just basic Perfmon information, and I generated a heat map. I just wanted to see per core what was actually going on when this thing was running. This is the heat map that I generated. This is per core on a 40 core, they called it an NPAR there. What we did, we just did some testing in there. When they ran this thing, this was the core part of the processing. And you notice red means really active, green means not active at all, and the darker shades in the middle are percent usage. So if you take a look, this thing was running single threaded. That's not cool. So tons of CPUs, single threaded processing, not good. And believe it or not, the CPUs that they had picked out per core were slower than the machine that they were coming from. A 5-year-old physical machine with 12 cores by 4 sockets per core was running 21% slower per core, so said Geekbench, than the chips that they were coming from. And it's scary. It's absolutely scary. So what did we do? I mean, we turned around and we ended up with some newer CPUs, things like that. It's a third-party vended process. There really wasn't too much we can do. The code was so ugly, it was running single-threaded, not as much tuning as we wanted to do there. Bottom line, performance is completely subjective. It's the whole, so you walk into the office on a Monday morning, somebody's standing at your desk angry saying, it's slow. Well, slower than what? Slower than yesterday, slower than every day in the last year at this time of day on this day of the week, or you just don't know. You, as the DBA, have to make this objective. You have to put some rationality behind this. There's no more arguments. There's no more finger pointing. You have objectivity on your side. And quite frankly, if something's running wrong, you know what it's supposed to be. You have the numbers as it exists right now, and you can see very quickly, is something wrong or is it okay? The numbers should be what actually drives the performance discussion. It gives you these symptoms and indicators of what's actually going on. I mean, it's not like these are just single isolated machines. This is a normal VM farm with a lot of databases, a lot of instances, a lot of VMs on there, cloud or on-prem. This is what's really going on. So it's not like one database is usually the primary consumer. Even if you only have one database or one instance, there's still virtualization in there. There's still shared activity on the hosts, shared activity on the storage. And who knows, what if everything's perfectly fine and all of a sudden your storage latency spikes? You didn't do this, it's something else, but you have the symptoms of it if you have that objectivity that gives you the data to go to the infrastructure team and ask them what's going on. So if I were to ask you some straightforward questions, do you have the answers to these things? For example, of all of your SQL servers, which one consumes the most CPU during business hours? Or which one are under memory pressure? And I know that's a loaded question because as DBAs, we want all the RAM in the world. But how much do we actually need? Are we under pressure? Can you give me the databases that consume the most throughput? Now, there's harder questions in there. What if we're able to objectively see when an antivirus scan kicks off on a terminal server on the same physical machine as my SQL Server VM, is that causing me problems? Is it slowing me down? Is it bottlenecking network or disk or anything like that? So what's going on? What happens to your SQL servers when backups kick off on other machines in your environment? Could flood the network, could flood disk, or even just random events. Do you have enough information to where things like random availability group failovers, can you go tell, what was going on at that point in time that may have contributed to this thing having a hiccup and failing over? It's tough. Now, if you've got any one of these third-party tools out there, there's some really good information in each of these. And, I have my favorites, but quite frankly, they all work great for depending on what you need to do with them. But getting some of the data out of these may be a little more interesting. A lot of these are built for operational monitoring and alerting, but they're not going to give you what is normally happening day in and day out. Some of them try, some of them do a pretty good job with it. But if you're not lucky enough to have any one of these tools, you've actually got something already. You have Windows Perfmon. Now, if you're running SQL Server on Linux, there's Sysstat and IOStat, and I'm working on some blog posts to try to get more information for you out of those. But for right now, we're going to focus on Windows. Windows Perfmon, built into pretty much every version of Windows since I've been alive, works really well. But it gives you information like this, which is arguably hard to sort through. It's just a jumbled mess, and it's kind of hard to go pinpoint what's going on when you need it, and it's even harder to get the information out of it when we care about it. We've got to get the meaning out of this thing. So we need the ability to show before and after we make system changes, or what a normal day is versus right now. The granularity of these things also matters. Some of those other utilities on the previous slide, they tend to roll up data or not retain a lot of the information, and it gets a little more interesting. An example of this, a while back, customer called up, we get 32 CPUs, things are freaking out, things are super slow. They were only averaging 6% CPU consumption. Well, why? I went in and looked, and yeah, somebody had changed CPU affinity on SQL Server, and it was maxing out on 2 cores and idle on everything else. Well, that's not cool. The granularity matters. They were trying to blame the network. It's like, no, it's not the network. It's just that. Granularity matters. If you look backwards in some of these tools, this is normally what you would see. An hour-long snapshot, give me a day, and then it looks fine, maximum consumption 50%. Well, what if we shorten the granularity to 5 minutes? That tells a completely different picture than the previous graph. They average out to the same thing. But in this case, you can tell they're running a process a couple times an hour, and it's pushing the CPUs a lot harder, but then it's dying back off. So a lot of interesting information you can get out of granularity. Be careful, some of these tools can't give you this. Also, you can look at before and after system changes. This is one where we went in and we adjusted some of the storage controllers on a given virtual machine. And you can actually see very clearly the before and after on this. So the Windows kernel time here, the system Perfmon counters, went in and basically went from being of an 8 to 12% average down to 2 to 4. big difference. And you can actually see up above here, the system responded by actually increasing the overall CPU consumption because it wasn't waiting on the Windows kernel and it was able to do more with it. So that before and after is big. And visually, if you can actually see this, picture says 1,000 words. People actually respond pretty well to these kind of things. Now, Windows Perfmon, you've got it built in. If you've never played around with this before, it's kind of interesting. We want to go collect the raw data. So there is a Perfmon how-to guide out at our website. Now, I'm comfortable putting this out there. I don't ask for any contact info. I mean, it's literally just a document. So, you know, hairflux.com, or in this case, I'll just do a little shortener. We've got hfxte.ch/perfmon. And it'll go straight out. It'll give you a PDF that you can download. You can follow this on your own. Piece of cake, just right there. So essentially, this tells you how to go set up Windows Perfmon. And I'll walk you through the document here so you can see it. It basically collects ongoing on your machine around the clock, 24/7. We're going to collect performance information. Now, for just normal performance collection, I've actually got a lot of the counters that we like to see, and I'm going to go into depth on those here in a minute. So memory, network, page file, disk, CPU, things like that. If it is a VMware-based VM, I have a handful of counters here. If it's a Hyper-V-based VM, I have a few more counters. If it's a Hyper-V host, there's a few more in here. And if it's a SQL server, I've got a bunch of counters listed here. All of these are going to give us really critical information from a top level down on what this machine is actually doing. Now, I want you to collect these at a 30-second granularity. A lot of these systems out there will do 5-minute or 10-minute or even all the way up to an hour or even 4 hours. 30 seconds gives you a lot more granularity. On average, you're looking at between 8 and 15 megabytes per day saved to the file system. So it's really not that much. So we go set that up. Now, we'll go in, we make sure it's due to start every day at midnight. We go in and make sure it's set to stop just before that day mark. So essentially, we're going to recycle every night at midnight. It has a different date stamp of the file name on the file system. And as a result, we now have a file per day. This thing right here, the data manager, also goes in and tells you how to make sure that this thing doesn't fill up the hard drive automatically. You know, that's never a good thing for a production machine. So every time it cycles, it double checks to make sure that we've got enough free space on the drive that you park these things on, or even number of maximum folders. And then if there's a problem, delete the oldest or delete the biggest, however you want to do it. Do that, and then we can tell this thing to go in and compress after a certain amount of time. So, you know, in this case, in 7 days, create a cab file, which is Microsoft's kind of old version of a zip file, and then delete the data files. Just frees up some disk space in there, no big deal. After 6 weeks, delete the cab. After 26, delete everything, and that way you just make sure that you don't fill up the hard drive, but you've got a pretty good amount of granularity on there. Do that. There's one little thing that you have to go do. You have to dig into the task scheduler, find the job under task scheduler library, Microsoft Windows PLA, because when I think Perfmon, I think task scheduler and PLA, right? Go in there. You need to set up one that turns this thing on if the system restarts. And then if it's already running, you can go in and tell it to stop the existing instance. And that way, when it cycles at midnight every night, you automatically get that new file. And that's it. It's pretty straightforward. Once you do 1 or 2 of them, it's really not that bad. Now, do the 30 seconds. Now, I showed you how to do the guide. Now, I'm going to walk you through the collection here. And actually, let me just show you a little interesting thing. github.com/hairflux. Okay, so raise your hand. I won't be able to see it, but how many people are upset that everybody on the internet tells you to go collect Perfmon and then they don't tell you what to do with it? So should be everybody. What we did a while back, I wrote something that allows you to take Windows Perfmon data and load it into a SQL server. So if you go github.com/hairflux, there's this thing out there, BLG to SQL, and all it is PowerShell with a database schema out there, and there's one for pre-2016 as well. So this one uses column store, the other one doesn't. And it gives you a bunch of queries out there that you can use to go mine this information. So completely free, wide open. If you like this, let me know. If you don't, tell me why, because I want to make it better. Okay, so now let's, actually, are there any questions up to now? And then we'll dive into the individual counters.
We have no questions. Oh, wait, we do have questions, unless they were just raising their hands. No, it's no questions yet. They're enthralled with the information so far.
That's awesome. Cool. If anybody's got any questions, feel free to put it in the chat window because I'm here for you. Okay, so now from a counter perspective, what are we actually collecting? So first of all, the processor, arguably one of the more important pieces that we care about here. It's broken up into 3 counters. So there's percent privilege time, percent user time, percent processor time. There's other stuff in there with ACPI, power saving states, and all that stuff, but these are arguably the more important ones. Percent processor time is really just the total of everything. Privilege time is essentially operating system level operations, such as network handling, storage handling, or things like Carbon Black or antivirus scanner, stuff that actually get inside the Windows kernel. This is where you would see it. Percent user time is the application CPU consumption. So SQL Server.exe, SQL Agent.exe, people already pinging in and running SSMS on your machines, stuff like that. You'd be able to see that there. Now, percent processor time. If you are very curious, you can actually look at the amount of CPU consumption by executable. So in a lot of cases, people freak out, oh, my SQL Server is eating 100% of my CPU. I get in, I take a look at this, and I'm finding that somebody misconfigured an antivirus agent and it's running in the middle of the day. And this other program is what's eating all the CPU. You can see that very clearly. There's a lot of counters in there. So usually I filter process out by just SQL Server and SQL Agent, maybe DTS server.exe, which is SSIS, and a few others. If you really want to see everything that's going on, you can collect it. It is a little bit of extra system overhead, not much, and a little bit extra disk space, but it's still not bad. Processor information, percent of maximum frequency. Now, if you notice, just looking at this thing right here, my CPUs on the machine I'm on right now rated at 3.6 gigahertz. Well, you notice right there, 3.99 or 4.6, 4.4, 4.49, 4.42. It's changing. Windows and the hardware can actually scale up and down the CPUs in order to try to save power, or in this case, turbo boost. Most of the time on a server, they're not really going to go above base frequency, but they may go backwards and slow everything down. If you see this number less than 100%, it means you have either core parking or frequency scaling going on, and that can actually hurt you on performance. So that means the Windows layer needs to be set to high performance. Maybe the physical machine firmware needs to be set there as well. Now, some indications of CPU scheduling pressure as seen by Windows. Context switches per second. Now, Microsoft has published a rule of thumb. Context switches per second greater than 5,000 times the number of processors that you have. They claim it is a symptom of CPU scheduling pressure. I would never claim that any one of these individually would be suitable to go do a knee-jerk reaction and go change stuff, but it is an indication that you might have CPU scheduling pressure, just like processor queue length. Microsoft's guidance is greater than 5 times the number of CPUs that you have. They claim that is an indication of CPU scheduling pressure. My warning line personally is 3 times. My red line is 5 times. And what you'll find is that most of the time, unless these machines are just really under stress, you're going to be far below that. Now, memory. Now, as a SQL server, I want all the RAM in the world. But realistically, do you need it? And one thing to really pay attention to is that SQL Server does its own memory management. So as a result, that buffer pool RAM, it actually hides what it's doing from Windows, which is really interesting when we're looking at memory counters. It's also part of the reason why a lot of these third-party utilities that deal with capacity management, they just get it wrong. They're just looking at either VM level changes or what Windows is telling them. It's not always the case. We have to go look at some of the SQL Server specific counters. So if you're just looking at Windows, there's available M bytes, available megabytes. I like to claim that that shouldn't get below 500 or 600 megs. Now, I know it sounds like a lot, but available RAM is essentially memory that has never been read from or written to, also known as free memory, but it's also got RAM in there that may have been used by something and then returned to the OS, and it just hasn't gone and cleaned it up yet. If you go below 90 megs available, Windows will actually issue a command that says, for all running processes, give me memory back right now. And then when it tops 150 megs, it goes, okay, you can go do what you want. So if it gets down that low, you're going to end up with this flip-flop of toggle states where the CPUs spike, everything slows down, and it kind of just bounces back and forth. And it's not really a good spot to be in because that means you're probably paging to disk, you're probably pushing the RAM a little bit too hard on there, and you probably need a little bit more, maybe. Now there's lazy writes per second. It's essentially memory that has been flushed back out to disk. Memory grants pending. It's stuff that's just waiting for memory. SQL Server generally doesn't really do too much of that here. Same thing with page faults per second, where it thought it was in memory, but it's not. Most of the time SQL Server is managing that, so what it's doing you don't really see here. Now, if you're curious, page reads per second, page writes per second, and pages per second, it's essentially what is the OS or some of these other processes on there actually doing. There is no right or wrong for that. It's more of just getting a good baseline for what it's normally doing. The SQL Server Buffer Manager, page life expectancy, and buffer cache hit ratio. Now, again, neither of these are, you really shouldn't make a knee-jerk reaction based off of any one of these. But page life expectancy, it's what SQL Server thinks is the average lifetime of data pages in your SQL Server buffer pool. The guidance there from the internet is all over the place. Most of it's just wrong. There used to be this rule of thumb of 300. Quite frankly, the more you have, the better, but there's limiting returns. If you're measuring your PLE in 6 or 7 digits, well, you've got data sitting in memory that's just not being touched at all. It's just sitting there. You may or may not need all that RAM. If you can count your page life expectancy on one hand, yet you probably need more RAM. Same thing with buffer cache hit ratio. It's the percentage of pages found in the buffer pool without having to drop back down to your storage. Most of the time, relational SQL servers, you'll find that your buffer cache hit ratio is well above 99% for all your business hours. PLE, if I see it dip during the day, I tend to be concerned. If I see it either flatlining or climbing and the numbers that it's at are in the thousands, you're probably okay. If it's way much higher than that, you may just not need all that memory. I'm not telling you to take it away, but you might have a lot more headroom in there than you think. Paging file percent usage, when you don't have enough memory or your SQL Server buffer pool has been pushed too high and you got locked pages in memory set and the OS doesn't have enough to do what it needs to do in the background, it may resort to paging. Now, heaven forbid, if somebody's running an application server on your SQL Server, that might actually page to disk no matter how much RAM you have. I know Power Builder is a prime example of this. I don't care if you have a terabyte of RAM, it's going to page. It's just built to do it. And it's arguably pretty silly. Network performance counters, these are usually pretty straightforward. How much am I sending? How much am I receiving? So bytes received per second, bytes sent per second. Convert that to megabytes. So divide by 1024 by 1024 again, and you can actually go look to see how much data is going in and out. You'd be surprised. The communication streams are usually pretty small. Now, some of my favorites here, if you ever suspect that there's a networking issue somewhere, you can actually see what the operating system is seeing in terms of network stability. So packet outbound errors and packet received errors. If something is dying midstream and you have to retry those packets, this is where you're actually going to see that. I've caught networking switches going bad. I've caught just weird routes around, big campuses of technology, and things can get put in weird spots. Now, another one, packets outbound and received discarded. These are the weird one. Even though nothing is really going wrong, Windows can choose to just throw away a packet and ask for it again just to slow the stream down. I've seen it do this when the CPUs are really, really, really busy. And if you see any of this stuff, watch out. Something's not right. And this is where you can take this information, go to your infrastructure team and ask them, just what is going on there? Why am I seeing this? And if you have this objectivity, they'll work with you. Otherwise, if you just say, yeah, the network's broken, they're not going to listen to you. They're just going to think it's just a DBA blaming the network because of something else. So have all this data with you. It really does help. Any questions so far?
Yeah, we got just a couple.
Cool.
Somebody asked, does processor count equal logical core?
Great question. Processor count will equal logical core. Now, the logical core, if you're running an Intel CPU, there's a good chance you have hyperthreading turned on. If it's a physical machine, if it's a VM, it can't see that. Essentially, you might have half the cores, and essentially the pieces of the cores that you're not actively using are presented as another core. That's hyperthreading. So be careful there. But yeah, that will give you the core count.
Okay. What do you do with the total memory and the target memory counters? I have read that target memory shows the memory that SQL wants to consume, but also that it is tied to the max memory setting. As I am monitoring target memory on some systems, there is a variation when max memory doesn't change.
It's a great question. That's not an easy one to answer. The target memory counter is a variable. It's based on what SQL Server thinks it needs, which is not entirely accurate because you may end up with queries with very large memory grants that are artificially bloating that. It might be the statistics are out of date or something big that's causing it to throw off that histogram and its anticipated needs. So essentially, whatever your max server memory is set at right now, how's your PLE doing? How's memory grants pending, buffer cache hit ratio, all of that, and as well as storage read demand, which I'll talk through here in a second. If you find that those are elevated, then maybe it's worth adjusting the buffer pool, giving it more memory, or even adding more memory to that server just to help it along.
Okay, fantastic. Hopefully that helps there. What happens when you use locked pages in memory for the VM?
Ooh. Okay, I'm gonna go off on a tangent on this one. If you're not familiar with the setting, locked pages in memory says, I wanna make sure my SQL Server buffer pool is locked from Windows. So Windows cannot ask for some of that memory back. Now, I always say this is a good thing to turn on. You mentioned a VM. The challenge here is that if a VM physical machine, the host that it's running on, is experiencing memory pressure, so VMware, Hyper-V, KVM, whatever, they all reserve the right to essentially find a way to steal memory back from some of these virtual machines to give it to others or to keep for itself just to stay stable. It's called ballooning. VMware's got that terminology in there. Hyper-V, the other ones, they still do it. They may just not call it that, or you may not see it too clearly. Here's the challenge. If the host is under memory pressure, it's going to look for the amount of memory that it thinks is going idle. Your SQL servers always have a very large memory footprint compared to the other VMs. The way the VM layer looks at what's called active memory is invalid for SQL Server. It does this because they don't know any better. As a result, your SQL servers are usually the first ones targeted for memory reclamation. When that happens, this little program in guest will, quote, balloon, and it tells Windows to start paging to disk. So Windows is going to start giving back memory and dropping down to the page file. The second it gets to SQL Server, it can't get that memory back, and it's trying and trying and trying. In the meantime, it's giving back as much as it can in the background for everything else. If the host is under memory pressure and this ballooning hits your SQL servers, there is a slim chance that the Windows layer can actually blue screen if the memory pressure is high enough. I've seen that multiple times. There's a worse condition. I actually saw one, and this is a one-off, but I saw where the TCP stack for Windows ran out of memory, but the persistent UDP connection to monitor the SQL Server up-down state stayed connected. The monitoring tool said it was up. All the end users said it was down. There was an 18-minute discussion while this thing was down at a financial group during trading hours. It was not good.
Wow.
Yeah, not a lot of fun. So long story short, at the VM layer, if there's any chance at all of the host experiencing memory pressure, there is a setting in all the hypervisors. In VMware, it's reserved guest memory, Hyper-V, same thing. It just says, don't allow the hypervisor to steal RAM from this VM. You can do it on others, but you can't do it on this one. If you do that, you can guarantee that you will never have that ballooning in your VMs, and as a result, do what you normally do. Set the buffer pool appropriately, leave enough headroom for the operating system, do lock pages in memory, because if you're doing that on Enterprise Edition, now you can enable large memory pages and get a performance gain. So
right.
long-winded answer there.
No, I think that's excellent, though. I think a lot of people are not aware of that, so good. We do have some more questions, but we can reserve this for the next set.
Okay, cool. Okay, so we've talked about CPU and memory. From a disk perspective, this is one of the bigger ones. Memory, fast. CPUs, you probably have a bunch. Storage is always variable. And the storage admins are generally a fairly closed group. They don't know the nuances of SQL Server. They just think that you're eating all their space and crushing the stuff when you run backups and index maintenance. And they always ask, is that stuff really necessary? The answer is always yes. So it's always an argument. When you have a lot of this information, this gives you more objective data on your side. First of all, physical disk counter. The set is the percent idle time. Now, this used to say the disk was idle this percent, kind of what the name implies. Nowadays, it's not as much of that, but I look at it as an indication of load. Essentially, how busy really is this thing? And again, take it with a grain of salt because it's not the most accurate anymore. But if this thing percent idle time is 0, you are stomping on that disk constantly. Now I'm going to go from the bottom up on here, sort of. Throughput matters not as much as some of the other ones. Disk read bytes per second and write bytes per second. Convert that to megabytes. That's throughput. So, just raw throughput on that drive. IOPS matter more than throughput. Disk reads per second, writes per second. This is what the storage vendors usually claim. Well, you can do 1 million IOPS. It's like, well, if the demand is there, great. Let's do this. But a lot of times you'll find that the demand for the peak IOPS that they claim just really isn't there. But what matters the most, that's latency. That's the round trip to that storage and back. So average disk seconds per read and per write. Convert that to milliseconds. This is what really matters. If there's congestion underneath or something really going on in the background, either on their interconnects or on the storage itself, this is one of your leading indicators. You will see disk latency rise here based on what you're doing, if there's any of these bottlenecks. Now, you may get into an argument with your storage admin. They might say, well, I'm looking at the SAN and there's nothing wrong. I don't see any of these latency numbers. Do not let them tell you that this stuff is lying. On any given system, there's at least 4 points between this number and what they're seeing on the storage array, sometimes up to 7. So what you're going to find is that this is a leading indicator on storage path congestion where things may be maxed out there. So just track this stuff. Now, if you're curious about how the disk is actually being used, a lot of people go think I can run like Crystal Disk Mark or Disk Speed or old SQL.io and get a good idea of how SQL Server is using the disk. That's not true. SQL Server is doing different block size patterns all over the place. So, a read may be an 8K read, or an extent as a 64K read, or maybe I'm doing backups in a 1 meg read or 1 meg write. Maybe my log files, they're actually writing in a 60K segment. It's kind of weird. If you look at disk bytes per read and per write, you can start to get a sense for what the disk pattern on that drive is actually like. If it's log files, you'll see a 60K read consistently. If it's a destination for backups, you'll see the 1 meg on there. It's interesting. And you can actually tune the storage and potentially even the pathing to get there to make sure that these blocks are actually okay. SQL Server, buffer manager. Buffer cache hit ratio, page life expectancy. We talked about those. SQL statistics, batch requests per second, SQL compilations per second, SQL recompilations per second. Very important. Again, there's no right or wrong. These are basically measurements of demand. If you see a system change, like you do a service pack or cumulative update install, and all of a sudden you see something change here, like compilations per second spikes, something's not right. We actually caught a bug a while back by watching one of these things change when we upgraded one from 2014 to 2016. SQL Server locks, lock waits per second. Do we need to figure out why these things are getting locked? Maybe somebody's running some goofy long-running reports or doing some ETL processing during the day and it's locking a bunch of tables. Just good baseline information. General statistics, processes blocked, so you can actually see the number of blocked threads. Database application, transactions per second, all good numbers to claim. So you can say, hey, our business this year has grown. We've gone from, let's say, 2,000 transactions a second to 5,000. Gives you some standing room to say, based on our growth, we need to build a system that can handle 10,000 transactions per second for the end of next year, things like that. Okay, so I talked about that. Here's the link, and I'm going to get the slides out to Leslie here when we're done, but that is the link to that Perfmon importer. And again, feel free, test this, explore this thing. It's actually pretty cool. If you use your imagination, you've got this in a database. We've all got our reporting and analytics tools of choice, and I'm not telling you to use any one of them. They're all awesome. In Power BI, and if you're like me, I'm not that visual a person, so just T-SQL and some of the windowing functions built into it. Whatever your flavor is, you've got the raw data. But throw away a lot of the misconceptions. This is just simply looking at a 5-minute average across each CPU core. Now, stretch your mind a little bit. What if you threw away the date but left the time? Leave the day of the week. Filter out Saturday and Sunday so it doesn't skew anything. Do a 5-minute average over each 5 minutes of the date, just the time portion of it. Display it. What you've got now is a 5-minute average per core across a given week. And you'll find that week after week, they're very similar. In this case, 8 p.m. hit, they had a single-threaded process that was doing a backup. They did hour-long reporting during business hours, started at 7 a.m. Things like that. You can actually see everybody got on at 7, a bunch more people got on at 8, a bunch of people took lunch about noon, and then not really as much work in the afternoon. So normal operating procedure. The cool thing is all this is in a database. So, if you take a look, you can actually go see, in this case, Perfmon import. Now the data that I'm showing the query here, they had a Star Wars thing going on in their office. So their SQL server's name was Chewie. Yeah, they ran out of names. They had to resort to the Star Wars universe to find more servers. It was funny. But yeah, you can say, give me the counter name, give me the set. Counter like SQL Server Buffer Manager or Page Life Expectancy. Just basic queries. Take a look at that. If you want to look at time by core, simple, basic stuff. You can slice and dice with Power BI a lot easier than this. I'm just not the most handy with it, so I tend to do it this way. Exclude everything like SQL Server. Give me everything else. Give me a time filter on there, however you want to do it. There's ways you could do dynamic pivot tables, and all of these queries are out there on that GitHub repo. So you can say here, give me the raw data, give me the CPU number, give me the counter itself, date and time, build a dynamic pivot table, which is not fun at all, and then you can turn around and you can actually get this kind of information by core. Again, all the examples are out there. Feel free to enjoy this. If you want changes to it, let me know. You can even build heat maps. You can do this with Excel. By core, just conditional formatting in Excel. It's 3 clicks to go generate a heat map. And even for the managers in the group, they can understand these. In this case, yeah, you're not using all the cores that you've got. Simple as that. You've got a handful in action here when something kicked on later in the day, with 6-8 cores busy, everything else is quiet. They were insistent that they needed more cores. They didn't, they needed less. Disk throughput, same kind of thing. Show me megabytes per second by drive. Same kind of thing. Normal SQL Server, this was read megabytes per second. Pretty active, but they had a hotspot. You see, during the day, it was just one drive that was the most active. In this case, what we wanted to do was have more data files, more file groups, spread them out amongst a couple of extra drives, get that workload really spread out more, and get better performance. IOPS, same thing. Show me IOPS by drive across the day. You can see, they were backing up their C drive there at about 9 at night. Different drive about 10 o'clock. That read activity that we saw with the throughputs, same thing during the day. Latency, you can see this is a good disk system. 1 to 2 milliseconds on most of the disks. That one hotspot, you could see they were in the 2 to about 10 millisecond range. But again, visualizing this goes a long way. You can actually see when things get busy and when things get pretty quiet. Page life expectancy, same kind of thing. Perfectly normal for PLE to crash when you do stuff like backups, integrity checks, index maintenance, all of that. During the day, in this case, you could see PLE dropped a little bit when everybody logged on first thing in the morning or when they tried to get a whole bunch of stuff done right before they went to lunch. As soon as they were done, it either climbed or flatlined. Do they need more memory? Just based on this indicator, probably not. I'd still want to go look at some of the other ones that we talked about, but this one honestly looked fairly normal. Same kind of thing. This one, PLE crashed at about 4 a.m., stayed there until about 5:30. That process was done, but everybody logged on at 7:30, and this thing stayed way low during business hours. This is one, they probably needed a little bit more memory, but we did that, page life expectancy, buffer cache hit ratio, memory grants pending, stuff like that, and it helped confirm it. But this gave the business case to say, hey, when everybody gets in the morning, this thing hits rock bottom and it stays there. Think a little bit bigger. Why just look at one machine? What if you want to visualize what everything in your environment is actually doing, or look at all of your SQL servers together? You've got the raw data. It's in a database, so why can't we do it? This is CPU consumption across 27 SQL servers. You can see one of them was really active right here at about 3:30 in the morning while it did some index maintenance on a massive table. Everything else was fairly quiet, but you can see our distribution during the day was quite even. This was a hosted environment. They had a good, solid distribution amongst all of their servers, and their customers were well spread out, so they really didn't have any crazy hotspots during the day. But all this stuff, use your imagination. You got the raw data. You can do so much with this. But at the end of the day, ongoing sampling really matters. Getting this performance information around the clock, 24/7, 365, having that history there gives you the ability to see what's normal and then compare what's normal with where you're at right now. Do the analytics, monthly, quarterly, whatever makes the most sense. You can use it for short-term performance triage, but the long-term capacity side of this is arguably more important, because then I can tell you how much SQL Server CPU core licensing are we really needing today. But based on business growth from 6 months or a year or 2 years of this data, where are we trending to? When will we get to the point where we need more licensing? Or what happens when I make when I spend a day a week doing index tuning? What happens at the end of the month? How did the consumption drop? How did I just save the company 50 grand worth of licensing? And can I get some of that back as a training budget so I can go to the PAS Summit next year? There's all kinds of stuff that you can do. Okay. What questions do we have?
Okay, so we've got, is there an automated way to roll out the collection process if you have a large number of servers?
Yes. And I'm glad you asked, and I'm going to put this out on a blog post soon. But what I want to do is I'm actually going to flash this on the screen and let you take a screenshot of it. This is something that I use with my consulting, and I'm going to open this up. If it is a SQL server with traditional default instance, so not a named instance, all you need to do is run this. This works on Windows Server 2012 and above, and this works with a default instance of SQL Server. It goes and fetches a PowerShell script off of one of our sites on the internet. The standard Windows counters get added on the first line. The second line does the SQL Server counters. The third one starts the task. That's it. If it's a named instance, I'm still trying to figure out how to programmatically do that. I've got a beta ready to go, but it's not ready for public consumption yet. But if anybody's interested, shoot me a message and I can get this to you on a list once I'm done with it.
All right, awesome. Okay, so when we had talked earlier about the lock pages of memory for the VM, and you went through that, this refers to that. So he says that was a compelling story about the potential impact of host hypervisor issues. Surely some situations would not lead to a blue screen, but can you offer us anything to watch for from within the GIST, Perfmon counters, or anything to tell if that problem may be happening?
Mm-hmm. Yeah, absolutely. The biggest thing is going to be the available memory counter and the page file % usage. The available memory counter, if there's pressure like that, you're going to see that drop to basically 0. You'll see the page file consumption start to skyrocket. If that happens, you can actually track the process's memory consumption, and you can look for the executable that's just suddenly expanding its memory footprint very quickly. And usually it's just a little tiny TSR that either VMware or Hyper-V put in there as part of the integration packs. That will actually give you very clear indications if that's running. Now that said, the VMware specific ones will actually give you the percentage ballooning. So actually, give me a second here. I can remote into a machine in my lab and I can actually show you this. Give me one moment here. While this is running, in that document, it actually lists one of the Perfmon counters that you can use. It's the VM memory Perfmon counter. So let's go, if I could type. So under Perfmon, I'll zoom in here momentarily. In the performance counter set, come on. You'll notice there is a counter called VM memory, and right there is a counter called memory ballooned in megabytes. If that number is greater than 0, and this is the VMware specific platform, that is the single easiest way that you can go tell that.
Awesome. All right, good info. All right, next one. Can you give examples of those 4 to 7 points between the VM and storage with regard to latency?
Mm-hmm. Yeah, so let's just say your average server environment. Let's go, normal piece of server equipment, normal storage. So let's say it's fiber connected storage. There is a queue depth setting in the fiber adapter on the physical machine called an HBA. By default, it's either 32 or 64. The faster your storage, the higher that number could go, but the storage vendors never tell you to go change this. That needs to be bumped up. If you're in a hypervisor, the driver side for that device also needs to be updated. If you go one step higher than that, then there's additional tuning at the data store layer. The data store layer inside the hypervisors might actually be a default bottleneck. For example, if I'm running all flash storage, my queue depth at the HBA might be 64. Let's say I bump it up to 256. Okay. Change the driver inside the hypervisor to match. So I've got 2 layers now cleaned up. If there's more than one VM on a data store, by default, the data store queue depth drops to just 32. If this is a VMware platform, the setting is called DSNRO, or disk.sched_num_rec outstanding. Very few VM admins know about this, but this particular setting can contribute to very high disk latency because the hypervisor itself has artificially imposed a bottleneck. It doesn't know what kind of storage you have underneath, so it just assumes you have the slowest, cheapest, crappiest storage possible. That can slow you down. If that is cleaned up, then if you go one step higher, you're at the virtual disk presentation at the virtual machine. By default, the VM admins know that they want multiple disks, but they just pile everything onto one disk controller on the virtual machine layer. Each one of those disk controllers has its own queue. You get up to 4 of those. So use all 4. Spread out your SQL Server objects, data, logs, tempdb, backups, OS, multiple data drives, whatever you normally do. Spread those out and distribute them amongst the available disk controllers. Bump the queues up that way. Now, VMware specifically, if you're using the Paravirtual SCSI controller, the default queue depth on there is 64. If you find you need more than that, that one is able to be updated with a registry setting that will let you go up to 254 per controller. Be careful with that. Don't go all the way up to 254 until you do testing and confirm that it does better. But if you clean up all of these queues from the bottom to the top, you can essentially double your storage performance on an all-flash array without having to buy a new array. It's big, big, big tuning areas.
Sweet. Awesome. Do you have a schedule on how frequent one should run the perf counters initially? Would it take a month to determine a good baseline? Then after the initial month, run those perf counters for a week straight, or what?
Man, these are great questions. Me personally, I would claim that it depends on the business patterns. Ask the business. Normally, a week usually is good enough, but a lot of times businesses may have certain things that either run on, the last day of the month or the first day of the month. So you want to understand what a cycle for the business really is. If it's a weekly cycle, run it for a week. Normally, I just leave them going. If it's more like a month, run it for the month. You can, with the Perfmon information that you've got in the database, you could say, my entire month, not including this one batch cycle that runs like mad on the first day of the month, looks like this. This extra day of the month really goes and it jacks the CPU up or things like that. It gives you that granularity. But yeah, minimum of a week, but just work with the business to figure out what their usage patterns are really like.
Okay, great. This is an interesting one. Are there good Perfmon counters to track SSIS workload?
Ooh, good question. I would claim that you should track the process counter for MSDT, or it's DTSRV.exe. It's basically the SSIS executable. If that's firing external things, you may need to figure out what else it's firing, but that would be about the easiest way to go track that. The hard part there is if you're doing a lot of stuff all at once, it's going to give you what SSIS as a whole is doing, but it's not going to be able to get too much more granular than that.
Right. And Tim Mitchell has some great SSIS performance stuff out there, so also look at Tim Mitchell's stuff.
Mm-hmm.
All right. This question may not be directly related, but for FCI of 2 nodes, do you suggest RDM or VVol or iSCSI? I don't know. This is way beyond my knowledge.
Yeah, it's not related to Perfmon, but it is related to virtual disk presentation for a failover cluster. I would recommend either a raw device map or a VVol. N-guest iSCSI is not where I would want to go with this unless you had to. So the others are a little more difficult for your storage admin and VM admin to manage, but it makes it a whole lot easier for you because then you don't have to manage an iSCSI target with multipathing and advanced VM networking and all this other junk.
Nice. Okay. This one's, he says this is oddly specific, but like that starts it off that way.
I was going to say I love it. Prefix
so
it like that.
Be prepared. Any suggestions for talking to the server VM team on a hyper-converged system where SQL servers are seeing ADSRS and ADSWS through the roof on the order of 4,000 to 6,000 milliseconds, 16,000 to 17,000 milliseconds at times?
Ooh, yes, I do actually. This is a hard one. What your VM teams have been told by their hardware vendors is that they just bought something that doesn't need a SAN and that it's perfect in every single way. That's what their marketing literature and their salespeople tell them. In actuality, what's going on here is that on a normal storage device, there are controllers, there's memory, there's CPU, there's code. All this is external to the CPUs that you need for SQL Server. That's why SANs are so expensive. They've got all this extra stuff in there. Hyperconverged, you don't have this. All the stuff that's handling I/O traffic and metadata management and compression and deduplication, it's the same CPUs that your SQL Server is using to run your queries. Their layer gets top priority, yours does not, and there's nothing you can do about that. The challenge here is that the act of doing all this stuff can actually cause CPU scheduling pressure and slow everything down. And what you need to do is to find out the percentage of CPU time that they're controlling virtual machines for their I/O layer, and there's one on every host. And this is SimpliVity, VMware vSAN, Storage Spaces Direct, Nutanix, all of these things. They all have those. Those layers consume CPU. What you have to do is to ask them for how much CPU and memory those things are actually taking. And if you can take that and overlay that when you're seeing these performance challenges, you might actually find that you have direct correlation when their piece ramps up to when your piece slows down. If you can go from there, there might be a way for them to go basically improve the storage handling of these things. And sometimes it means adding more memory to their controlling appliances. Other times will actually reduce the I/O workload with more RAM for SQL Server, things like that, just to basically dial back the hyperconverged I/O activity just to make things quicker. You know, I'm sorry you're dealing with this, but hyperconverged and large SQL servers generally don't play well together, and this is one of the trade-offs that you get with that platform. It's not the most fun spot to be in.
All right, and remember, all this is being recorded, so you can come back to the YouTube channel, pull up the session, and go play it for that server VM team, so they can hear it from the expert. Okay, so fantastic. So we're going to go ahead and call it. If I didn't get to your question, you feel free to reach out to David. He's a fantastic person. Will always respond. Thank you, David, for joining us today. Your knowledge and expertise is wonderful, and we love it when you share with us.
That's awesome. Thank you.
So everybody have a great holiday, New Year's, Christmas, Kwanzaa, whatever you celebrate. Maybe it's a SQL Server celebration. Have a great time. Stay safe out there, and we'll see you next month in January. Thank you much,
Sounds
David.
good. Thank you. Thanks everybody for attending. I really do appreciate it.
Yeah, awesome. All right, bye, y'all.